Analysis of Structure, Chapter 5, Part D. In this part, we divided into two sections. First section will discuss on the extension of Part A, which is the analysis of truss by using method of join. The second section we will discuss on the different method, which is by using method of section. In the section of by using method of join, we have joins under special loading condition. Forces in opposite members intersection in two straight lines at a joint are equal. We can see from the first diagram, which is two members intersect at point A or joint A, and we can see from the free body diagram produced, we have four forces acted opposite direction, which is we have force FAE is equal to force FAC, and we have another force, we have FAD is equal to force FAB. If we rearrange the direction which followed by head to tail arrow, so if you can see here, there is a net force is equal to 0 due to the head to tail, and finally the final arrow will come to the origin. The loading condition, which is the forces in two opposite members are equal when a load is aligned with a third member. The third member force is equal to the load including zero load. And then we have the force in two members connected at a joint are equal if the members are aligned and zero otherwise. Finally, recognition of joints under special loading condition simplify the truss analysis. So during the process of getting the value of forces act on each member, we can see a different structure of trusses. So this condition basically can make simplified in order to solve the problem. So let's see, in this condition we have zero force members. Many times in trusses there may be joints that connect members that are aligned along the same line. So let's consider this diagram. Okay, if we consider at joint E, so we have four members connected together, and from the point E we can create or draw a free body diagram, something like this. So we have the force act upward is the force AE, and then downward we have EG, and we have the force DE and EF. So in order to get the value of AE, EG, DE and EF, so let's we consider the net force of X axis is equal to 0. So we have EF at a certain degree, and we have a DE at a certain degree. So for the net force of Fx is equal to 0 can be identified as EF cos theta minus DE cos theta equal to 0. And from this diagram, supposed to be these two angle is supposed to be the same. So we can obtain the value of EF is equal to dE. Also, for the net force, Fy is equal to 0. So we have this one, this couple of force is along the y-axis. So the value of AE minus EG is equal to 0. Finally, we have AE equal to EG. Let's consider same thrust but different external load in these figures. Figure on the left side, we can see the location of external load downward at point C, and another one we have a external load location at point B downward. So let's consider at joint B. We have three forces acted on joint B. We have FBA to the left, and we have FBC to the right, and we have FBF downward direction. So if we calculate by using net force equal to 0 for each axis, we will get the FBC. For the x-axis, we have FBC is equal to FBA, and another one we have at y-axis, we have FBF is equal to 0. So once member on BF position is equal to 0, so we call it a zero force member. Another one, let's consider at joint C. We have two forces acted by force FBC to the left, and we have FCF. So finally, we have FCF is equal to 0, and we have for the x-axis, we have FBC is equal to 0. This point, at this position of point C, both forces is equal to 0. So that means we call it these two forces is zero force member. So let's consider for the exercise 1, identify the zero force members. We have many members, and we have many joints together, attached together, and we have external force act on joint A. By using the net force, we simply can identify the location or the members, we call it zero force members. So in double red line, we can see there is a 7 zero force member on this truss. So if we know this condition, so it is very easy for us to answer the question. It can make simplified of the process. Space trusses. An elementary space truss consists of 6 members connected at 4 joints to form a tetrahedron. We can see joint A, B, C, and D. We have 4 joints, and it produces 6 members. So a simple space truss is formed and can be extended when 3 new members and 1 joint are added at the same time. So we can see from the second diagram at the bottom. Okay, it will produce 9 members, and we have 5 joints. this condition is valid for the equation of n is equal to 3n minus 6. Condition of equilibrium for the joint provide 3n equation. For a simple truss, 3n equal to m plus 6, and the equation can be solved for m member forces and 6 support reaction. Equilibrium for the entire truss provides 6 additional equations which are not independent of the joint equation. Let's see a problem number 1. Now we can see many members or many triangle produce a truss. Okay. By using the method of joints, determine the force in each member and truss. Basically, when we determine the force, each force, we will need to answer the tension or compression for each member together. So the step by step for solving this problem basically is the first one is based on the drawing a free body diagram of the entire truss. Solve the 3 equilibrium equation for the reaction at E and C. So we have a hinge at point C and we have a roller at point E. So basically it will produce a reaction. So we need to draw a reaction force, and from there we will start at joint A in order to get the value of unknown member at member forces. Okay, and then in succession of doing to get the value of unknown member at joint A, we will proceed to determine unknown member forces at joint D, B, and E from joint equilibrium requirement. And finally, all member forces and support reaction are known at joint C. However, the joint equilibrium required may be applied to check the result. Okay, basically, at joint C, once all joint already calculated to get each member's forces, so at joint C, basically we use to check whether the answer is correct or not. Okay, by using net force is equal to 0. Let's go proceed one by one, okay, in order to solve this problem. Okay, basically we have in this diagram we have a reaction force at point C and point E. At point C we have a two forces reaction to have a component of Cx and Cy, and we have at point E, which is a roller, will produce a reaction, only one force reaction, which is E, upwards. All the value of E and Cy, basically we put outward direction, and Cx, we put a positive value. Okay, positive value. Whether you want to put Cx to the right or to the left is up to you. Okay, the first thing we need to use a moment at point C, okay, to we use a moment at point C to get the value of reaction at point E, or we call it EY. So from this equation, so we need to consider only 3 forces acted on according to this moment at point C. We have 4.5 kilonewton, and then we have 9.0 kilonewton, and another one is force from a reaction at EY. So three forces act together. So once you get the value is positive value, so the assumption of reaction force uh, towards upwards is correct. Why we set the moment at point C is equal to 0 and not at moment at point E? Because of at point C, there are two forces, Cx and Cy. Once you set the moment at point C is equal to 0, so you have three forces. Two forces is known and one forces which is Ey is unknown. So very easy to identify the value of Ey. Once you set the moment at point E is equal to 0, so you have a trouble because of you have four forces in your equation, whereby two forces is known and two forces is unknown, is from Cx and Cy. So you cannot get the value of Cx or Cy. So it's very difficult. So the best way is to start at moment at point C. So then we will use the net force at x-axis and y-axis to get the value of Cx and Cy. So you can choose whether you want to start from axis, x-axis or y-axis. It depends. Okay, once you start at, let's say at y-axis you stuck, so you better start at x-axis. In this case, we start at x-axis is equal to 0 for the forces. So we have Cx is equal to 0. So that's mean in this position component of Cx there is no forces, no force. Okay, and for the forces, the sum of forces at y-axis is equal to 0. We have 4 forces acted on the thrust, which come from 9.0 kilonewton, 4.5 kilonewton, Cy, and finally we have Ey. So Cy and Ey is positive direction and the rest is negative direction. So we have Cy plus Ey minus 9 kilonewton minus 4.5 kilonewton is equal to 0, and finally you will obtain the value of Cy is equal to negative 31.5 kilonewton. So the value is negative, so Cy you preset for the Cy is upward direction, basically is wrong, so the correct one is downward direction. So for the reaction at point E and C, by using this method we can easily get the value. Next we will start at joint A to get the value of two unknown members force. You can start at D, join D, E, B and C, but if you start from those join, it will difficult, it will become more difficult because of many unknowns member. Okay, so at point A we have three forces acted on point A. So one is come from external load, for the value is 9.0 Newton, and basically in order to solve this problem, this member we will need to assume that all member is in tension. So the force acted on point A basically out of point A. So the force of FAB to the right, and we have the force of FAD and to the downward direction. In this case, we can solve this problem by using the net force is equal to 0. You can we can start whether by using the net force at y-axis or net force at x-axis. Once you deal with, let's say, once you deal with x-axis and there is a there are two forces unknown, so you will start there and then you try to solve by using a y-axis. So at y-axis we have only two forces, which is 9.0 kilonewton, and another one is the force of FAD only. If you solve by using x-axis, you have unknown force, which is FAB and FAD, so very difficult. Once you start by using y-axis, so you will get the value of FAD is equal to negative 11.25 kilonewtons. Okay, and the correct value is 11.25 kilonewton, which is compression, because in the first place we already said FAB is in tension. So once we get the value is negative, so we will change to the compression. So the sin theta, basically we will use the triangle concept by using the triangle. So in this case, we no need to identify the value of the angle value. So just proceed by using trigonometry, okay, theorem Pythagoras. So we have this triangle is 1.8, 2.4, and 3. So basically by substituting sin theta is equal to 2.4 over 3, and finally we obtain the value of FAD. Once we obtain the value of FAD, so it's very easy to us to calculate the value of FAB by using net force at y at axis is equal to 0. Okay, at this time, okay, we have FAB minus FAD cos theta is equal to 0. Okay, by using a triangle, and then we substitute cos theta, which is 1.8 over 3, and finally we obtain the value of FAB is equal 6.75 kilonewton. You must be remember, because of the value of FAD, basically when we redraw the arrow of FAD is basically in opposite direction from the first diagram, because of once we discover that FAD is a compression, okay, we need to redraw the direction of FAD. Okay, the correct diagram of second draw, okay, we can use it to get the value of FAB, and finally we obtain the value of FAB is equals to 6.75 kilonewton, which is the at the first place we said FAB is a intention. Other method by using a triangle, so we can set the triangle at something like this. We have a 9.0 kilonewton and we have FAB and FAD. So by using the triangle in mathematical technique, so we have FAD is basically divided by 3. Okay, this one you can compare to the triangle that you use to get the value of sin theta and cos theta. So by using that, you can compare, whereby the value of FAD divided by 3 is equal to FAB divided by 1.8, and then is equal to 9 kilonewton divided by 2.4. From there, you can get the value of FAB and FAD. Basically, the force in equilibrium when we draw must be follow head to tail method, whereby we have FAD head and then follow by tail of 9.0 kilonewton and follow by tail of FAB. This is indicate that this diagram, the net force is equal to 0. Once if you cannot get this head to tail method, there is no net force. Okay. So and then we follow proceed to next point, the next joint, which is we start at D, which is at joint D. So at joint D we have FAD. Just now we calculated and we get 11.25 kilonewton, and we have two unknown forces, which is FAB at a certain degree angle, and we have FDE to the right. Must be remember that two unknown forces must be set at tension, whereby the arrow is away from the point of D. To make it easy, we need to start calculate the value of FDB, because of whereby we use net force at y-axis is equal to 0, because it's involved only one unknown. Okay, so during the process, we have the value of FAD basically at certain angle. So and also have the value of FBD at a certain angle. So by using the sin theta, and we substitute of FDB sin theta, which is 2.4 divided by 3, and we have FAD sin theta, the theta is to also the same value, and finally we obtain the value of FAB is equal 11.25 kilonewtons. Okay, this is the correct direction, and we state as a tension. And the next we proceed for the net force at axis is equal to 0 due to the two unknown. So we have three forces joined together in this calculation. So we have FDE, and then we have FDB cos theta, and we have FAD cos theta is equal to 0. And then we calculate by substituting the value of cos theta, and finally we obtain the value of FDE is negative 13.5 kilonewton, which is the preset of tension is wrong, so the actual direction is opposite direction. So the final value of FDE is 13.5 kilonewton, which is compression. Another method which can be used by using a triangle method. Okay, and basically we can rearrange the arrow. So basically in this arrow of DE is wrong. Okay, so this FDE is supposed to be a left direction. So we can get the head to tail method. So when we set for the FD redraw for the FDE to the left, we can see one circle of head to tail triangle. So once we compare to the dimension of triangle from the measurement given, so we can set the value of FDB and FDE by using this triangle method. Okay. Okay, and at joint B, basically, we will have five forces, whereby we have three forces known and two forces unknown from FBC and FBE. So we will choose by using net force is equal to 0, whether which one is can be proceed or not. If only one unknown, we can proceed to get the value. In this case, we have net force at y-axis is equal to 0. So here we have for the y-axis, we have only FBE is unknown. So two forces from 4.5 kilonewton and force from FDB, which is known. So we can proceed there. So by using the y-axis, finally we have the value of FBE is negative 16.88 kilonewton, which is we set the first is tension, but the correct answer is 16.88 kilonewton in compression. And then we proceed to get the value of FBC. So and then finally we obtain the value of FBC is equal to 23.63 kilonewton, which is in tension. Okay, at point E, so we have four forces. Okay, only once we don't know, we call it unknown at force at FEC. From there, you can proceed whether because this is only one force, so you can proceed by using y-axis or x-axis. In this case, I use x-axis. So and finally, we obtain the value of FEC is equal to 39.4 kilonewton, which is the compression. Okay, and finally at point C, which is actually the value of all members, we already get the value, but if you proceed to at point C, you just calculate to check the result. Okay, so if you proceed by using a net force at axis, so you will get the value of is in equivalent. Okay, in equivalent, whereby the left value is equivalent to y value, and also you can proceed to y-axis, whereby the value is in equilibrium. Okay, so for the thrust, there's a lot of members and joint, so it's very tedious way to get the value and condition, whether tension or compression. If we get the complex thrust and many thrusts involved, so during the process of getting the correct value is quite tedious. So maybe you will get this kind of problems. So we have many members, and if asking for the value of EG, okay, force at EG, let's say, or at CE, so you need to start from point A, point B, point C, and finally you will obtain the value of EG. Okay, take a tedious way to get the value. But in this case, by using method of join, so we will have to calculate. Okay, basically, if something like this, okay, we have many members. So we have 13 members. So you need to calculate all 13 members in order to get the value, and you need to set whether it's tension or compression. Okay, by using this technique, it's quite tedious. So by using by using of method of join, so in order to make it simplified or make it very fast and easy to calculate at, let's say, at force at EG, so we will need to have another method. We call it method of section. Okay, later on we will go for the method of section. So how to manage or to get the result from this complex trusses. Okay, and then this one is a comparison between the Pratt truss and Howe truss. We have different condition of tension and compression, whereby for the Pratt truss we have all in tension, and at the upper chord is compression and lower chord is in tension. But in Howe truss we have a different, quite opposite value. Okay, okay, and then we will proceed for the analysis of trusses by the method of section. So if we discover that there is a complex and many members involved in these trusses, so we need to simplify. We need to use a very fast method. Okay, in this method, basically, when the force is only one member or the force in very few member, basically we will use a method of section. If many, so we need to have this by using this method, which is a method of section. Okay. So to determine the force in member BD, okay, let's say if we want to determine the value of member force on member BD, you need to make it a cross section. Okay, you need to cut along the three members BD, BE, and CE. So you need to cut it in half. Okay, so basically we will cut in half. Okay, but in this diagram we cut in half, but another diagram very complicated, we will cut in, it depend on what the question is asking. So and then we draw a free body diagram, okay, in this below in this figure below. So originally we have external forces from P1, P2, and P3. So once we divide by 2, okay, at the members of BD, so we have it will just produce another external force. We will say that we have FBD, and then we have FBE, and we have FCE. With only 3 member cut by the section, the equation for static equilibrium may be applied to determine the unknown member force, including FBD. So from there we will proceed by using net force is equal to 0 and also the moment at particular point is equal to 0. Trusses made of several simple trusses. This one maybe you can read by yourself. Okay, the equation with connected of members joint and reaction, okay, from the non-rigid and rigid truss. Okay, let's say we go for problem number 1. Okay, we have a truss, we have a hinge and roller. So at point C and point F we have external force, which is at point C is 80 kilonewton to the left, to the right, and we have point F, joint F, we have downward direction, indicates the value of 50 kilonewton. So by using this method of section, determine the force in member BC, CE and EF. So in order to set the value, we need to consider two things. The first thing, you need to consider the external force first. Okay, you try to get the value of AX, AY, and then DX, DY. Okay, and then later on, and then you proceed to get the value of each member. Okay, for in case of this question, we just cut into half from the members of BC, EC, CE, and EF. What we need to do is determine the external reaction. Okay, by using the moment at point A. Okay, we have at point A, so you can start at point D or at point A moment. So at point A we have a two reaction force AX and AY. So that means we will eliminate at these 2 points by using a moment at point A. So we will get the value of point D. Okay, reaction at dy. So this by using this method, we only have three forces: 80 kilonewton, 50, and dy. So from there we can calculate and get the value of dy. In this case, we have 53.33 kilonewton. So the value is the direction is upward direction. Okay, and then we will cut the truss into half so that we have and it will act as a it will produce as FBC, FCE, and FEF upward from the point. So this means we will, from here we will assume that this member is in tension. Okay, so by using this, basically we have in order to get the value of FBC, FCE, and FEF, basically you can choose whether whether the point you want to start, whether you want to start at C, whether you want to start at F, you want to start at E, okay, or you want to start at D. But basically, once you try to start uh, at C and E, you can get the value, okay, but it's depend on the question, okay, the structure. Okay, in this case we will start at point E. We start at moment at point E is equal to 0. So at this case, all forces towards the point E is basically we will eliminate. In case of toward at point E, we have FCE, okay, already eliminate, and we have FEF already eliminate. Okay, and then we have only 4 forces acted on this point. We have FBC, and then all three forces value from 80 kilonewton, 50 kilonewton, and value from dy, which is from equivalent to 53.33. Once you substitute all together in this equation, and finally we will obtain the value of FBC is equal to 4.445 kilonewtons, which is in tension. Okay, so the direction is to the left. Okay, so when you start at moment at point E, you will get the value of FBC. What about the value of FCE and FEF? So at this point, you need to select another point, whether at point C, point F, or at point D. In this case, we will start to get the value of FEF by using the moment at point C. Okay, at moment at point C, basically we have only 3. By using the moment at point C, so we have only 2 forces involved. The first one is from dy, and then the second one is from FEF. So all forces, the rest of forces is towards to the point C. So we will eliminate the force. And finally, we'll get the value of FEF is equal to 71.11 kilonewton. So now we have 2 forces calculated. The first one is FBC and second one is FEF. In order to get the value of FCE, we will use a net force. Okay, net force basically net force in like we will do in determining the whole body, the whole structure. So we have the whole structure. In this case, FBC, FCE, and FEF, we will see as external forces. Along we have 3 forces from the reaction from dy and 2 forces 80 and 50 kilonewton. In this case, in order to get the value of FCE, so we will use a net force of y-axis is equal to 0. Okay, once you, in this case, we have 3 forces involved from dy, okay, because it's from y value, and then we have 50, and in another one is from FCE, which is a y component by using a sin theta. Okay, by substituting the value, and finally we have the FCE is equal to 5.55. Okay, you can proceed by using the net force at axis. So in this case, we have many forces. Okay, so it's quite long time to solve this problem. By using the y-axis is very short time. So if we compare by using method of joint and method of section, in this case where there is a many members, so if we use a method of section, is very easy, okay, if compared to method of joint. Okay, for the problem number 2, okay, we have many members build this truss, okay, given 2 external force, which is this 36 kilonewton at point D and point F, and given the dimension of 4 panel at 2 meter is equivalent to 8 meter, and of course we need to use a method of section in order to get the value of BD and CD. Okay, in this case, this question asking for value of BD and CD only, but if we can also get the value of CE. Okay, along the way we need to make it make it cross sectional of BD, CD and CE. Okay, the process of getting the value is basically the same as problem number one. Okay, but in this case the question is not asking for the CE. So firstly, we need to determine the external reaction. So we need to draw a free body diagram whereby we have a hinge and roller. So at point A, we have a reaction force AY and AX. And then we have a reaction force at point H, we call it HY. So in order to get the external reaction of this reaction value, so we use a moment at point A is equal to 0, and finally we have the value of Hy. So in this case, the value is 45 kilonewtons at upward direction. And also we will get the value of Ax is equal to 0 and Ay is equal to 27 kilonewtons. And then we will proceed to get the value by using a method of section, whereby we cut the members at B, D, C, D, and CE. Okay, in solution 2, whereby we have this figure, we reconstruct again the figure, and whereby we have four forces. In order to get the value of FBD, we will need to have a moment at point C. Okay, so we will get which is involved two forces from FBD and AY. So in this case, the value of FBD is negative 36 kilonewton, which we set in tension, and the correct value is 36 kilonewton is in compression. Okay, you will also can get the value if you set from the moment at D. If you compare with problem 1, we will use at point D, whereby the point D we will get the value of FCE. But in this case, the question is not asking for the FCE, so no need to do a moment at point D. Okay, and finally we will get the value of FCD by using the whole structure by using net force is equal to 0 at y-axis, and finally in this case is involved of two forces AY and FCD. So FCD, you need to get the component of y. So by using sin theta is equal to 1.5 divided by 2.5. And finally, you obtain the value of FCD is equal to negative 45 kilonewton, which is the correct value is 45 kilonewton in compression. Finally, we have a problem number 3, quite complicated. By this one is any forces, external forces, which is come from 1 kilonewton to the 5 kilonewton at a certain point or joint. So asking for the FH, GH, and GI. Okay, we need to follow the step by step in order to obtain the value. Okay, the first step, we need to get the reaction at A and L, but basically we need to draw the free body diagram, which if at point A is a hinge, whereby we have two component of AY and AX, and the second one at point L we have LY. So by using the moment at point A, basically we will have a value of Ly. In this case, you need to compute all external forces from 1 kilonewton to 5 kilonewton according to the distance from point A. So finally, we obtain the value of Ly is equal to 7.5 kilonewton upward direction. So the rest of AX and AY can be calculated by using net force is equal to 0, and finally we obtain the AX is equal to 0, and we have AY is equal to 12.5 kilonewton at outward direction. Then again we need to cut into half from the the question required us from the FH, GH and GI. So we will cut into half, and then we will choose whether we want to proceed moment at which point, which depend on what you want to start. So basically at point H, okay, if you set at point H, basically you will get the value of FGI. So it's better for you to compare from the problem 1, 2 and 3 given here. So you compare and then you decide which point you want to start first. Okay, which point you want to uh, very easy to get the answer. So in this case, we start at point H. The moment at point H is equal to 0, and finally we will get the value of FGI is 13.13, which is tension, and next get the value of FH. This one basically you need to quite challenging because of is the value of triangle. Okay, 15, the triangle you need to use is basically you need maybe you need to calculate it first. Okay, in this case I use a value of the biggest size of triangle, which is 8, 15 and 17. So in this case at point by using moment at point G, so we will get the value of FH. In this case, the 4 forces involved from the Ly, and then from the 1 kilonewton at distance of 5 and 10, and also we have X component of FH. Okay, X component of FH, which is at point G is distant 8 meter. So you will also can be used at 8 meters. Okay, so at this so you all the value of FH cos theta, so you substitute of cos theta from 15 over 17, and finally you obtain the value of FH is negative 13.82 kilonewton. The correct answer is 13.82 in compression. And finally, for the value of F, wrong typo. So in order to get the value of FGH, okay, so we will start to get at moment at point L, okay, at point L. So this one by using a triangle, or you can proceed by using a angle. Okay, from here we calculated the angle is 43.115. Or you, if you want to use a triangle, we set the triangle value. So, and then by using at point L, okay, involved with three forces which come from the one both 2 kilonewton at 10 meter and 5 meter, and the another one is from FGH component from the y-axis. This one by using a cos theta. So, and finally the value of is negative 2.06, and the correct answer of the FGH is 2.06 kilonewton, which is in compression. So if you don't want to use a moment at point L, if you compare a moment in the problem number 1 and number 2, maybe you can use a moment at point H. Okay, point I. Okay, you can try whether it's okay or not. Okay, so the rest is a problem. So maybe you can try to get the value of the answer of three question problem, three problem. So if you have any problem, we can discuss together. Okay, so the problem number 4. Okay, maybe you can proceed by using a method of section. Okay, asking for the member forces in member of EF, JK, and HJ. Okay, thank you very much. Okay, we will proceed to part C later on.